Hello, grade 9. So we're starting chapter 7 today. We are looking at properties of 2D figures. So we're going to start off by reviewing some basics that you should have covered in elementary school, but I will review with you again today. So first of all, when we're labeling angles, notice I have an angle drawn here. My angle is 65 degrees. When I name this angle, I have a few options. I could name it simply as angle B, because that's the vertex of my angle, or I could also label it angle ABC. And I also have the option of labeling it as angle CBA. So it is longer when I label it as ABC or CBA, but sometimes it's necessary to use 3 letters to label an angle. And when we do this, it's very important that the vertex B is always the middle letter. Okay, I cannot call this angle BAC. That would be incorrect. It has to be angle ABC or CBA. Okay. Finding the measure of an angle. So first of all, I have a triangle here. 2 sides have been extended in my triangle. Within my triangle, I have 180 degrees. That's every triangle. So looking at this triangle, angle A, that's 85 degrees. That's already labeled for me. Angle D, that's 30 degrees. Again, that's labeled for me. Angle BCE. So starting at B, then C, then E. So I'm looking at this inside angle here as I draw BCE, and that's labeled as 55 degrees. And finally, angle ACB. ACB, that would be this angle here, which is 125 degrees. Right angles. So first of all, I denote a right angle with a box there. Okay, and that tells me that my angle is 90 degrees. When I have 2 angles, you can see this right angle is split into X and Y. These 2 angles, X and Y, they will add up to 90 because angle ABC is 90 degrees. When 2 angles add up to 90 degrees, they are called complementary angles. Simply means they add up to 90. It does not mean that they are each 45 degrees. It could be, but it could also be 80 and 10, 70 and 20, etc. A straight line. So here I have a straight line. A straight line, if I were to take out my protractor and measure, I would see it's 180 degrees. If I'm looking at my straight line here, WY, I split it at the vertex X so that I have angle A and angle B. Well, these 2 angles A and B, if I add them together, again, I'll get that straight angle of 180 degrees. When 2 angles add up to 180, the word is supplementary. These 2 angles are supplementary to each other. They add up to 180. Again, they are not necessarily 90 degrees each. It could be any combination of 2 numbers that add up to 180. Triangle properties. So we learned back in elementary school that we have different types of triangles based on their side lengths and also based on their angles. First triangle we're going to look at is a scalene triangle. That tells me that all 3 sides and all 3 angles are different. An isosceles triangle, that's a triangle that has 2 equal sides, and the 2 angles opposite those equal sides are also equal. A right triangle has an angle of 90 degrees in it. An equilateral triangle has 3 sides that are all the same in length and 3 angles that are all the same in length. And since we only have 180 degrees, these angles must be 60 degrees each. Continuing with triangle properties, so I mentioned earlier, inside of a triangle, X, Y, Z, those 3 angles there, they always add up to 180 degrees. If I were to extend the sides of my triangle, what I've done is I've formed 3 new angles. These are called exterior angles, and they have a property such that angle A plus B plus C, my 3 exteriors, will always equal 360 degrees. Furthermore, this angle here, angle A, it's equal to the opposite 2 interiors. So it's equal to Y plus Z. Angle B is equal to the opposite interiors, X plus Z. And angle C is is equal to the two opposite angles within the triangle x plus y. Parallel lines, so we denote parallel lines with these chevrons. That means parallel. Okay. So when parallel lines are crossed by a third line, that's called a transversal, that third line that intersects my two parallel lines. And a transversal creates many angles, a lot of which are equal. Again, this is all material you should have covered last year. I'm just going to review it with you quickly. So first of all, we have alternate angles. These form a Z pattern. If you can imagine drawing the letter Z, the two inside corners are equal to each other. So looking at my two parallel lines, I've got this Z right here, where I've got angle 3 will equal angle 6. And I can also draw backwards Z. So if I look at my backwards Z, angle 4 will equal angle 5. Corresponding angles, these form an F pattern. So if I construct an F, again, those two angles tucked inside the corners there, they again are equal. So there's a letter F. So that means that angle 4 and angle 8 are equal to each other. I also have this backwards F, so 3 and 7 are equal to each other. Then I also have an upside down F, 1 and 5 will equal each other, and upside down backwards, 2 and 6 will equal each other. Opposite angles, these are angles that form an X pattern, and in my X pattern, the angles that are opposite each other, tucked in opposite, are equal to each other. So I have two sets of equal angles. So if I'm looking here, I've got an X pattern, 1 equals 4, 2 equals 3. Another X pattern, 5 equals 8, 6 equals 7. And finally, co-interior angles. So these form a C pattern. So with the C pattern, my angles are supplementary. They're not equal to each other. Recall the word supplementary, it means that they add up to 180 degrees. So back to my diagram, there's the letter C right there. So tucked in the corners, I've got angle 4 and angle 6. If I add those together, I will get 180 degrees. Also, backwards C, angle 3 plus angle 5 will also equal 180 degrees. So, for homework, I'd like you to look at these pages here. If you have any questions, please reach out to me and I'll be happy to answer them for you. Have a good day.